How's it going, guys? So this is the next stream where we're coding Minecraft live, and in this stream we're just going to be continuing with what I left off with the last session, which is still optimization. So this one we should definitely be finishing up the optimization, and everything should start falling into place, and we should be in a pretty good spot by the end of this. So I went ahead and did some refactoring because I was crashing whenever I would end the game and stuff. And that was just because I had some memory write issues, so I was writing to invalid memory and stuff. So now we can generate the chunks that we had, all fine, and we don't have any errors. And I also just updated like my memory management stuff and my logger and everything so that everything is just a bit more solid. So yep. And how's it going, Flare YouTube? Hope you're doing okay. So yeah, we don't get any crashes when we exit now, so that's good. And in this episode, what we basically have to do now is finish this last little bit in the shader, which is getting this texture coordinates into this data, except we can't get it into this data all because there is one problem. Like once we get the texture coordinates into this data, we also need to figure out which texture coordinate to use: top right, top left, bottom right, bottom left. Unfortunately, we can't really just figure that out based on which texture we're using. So I will have to go ahead and say layout location equals 1, and I'm gonna have to add in one more uint, and this is gonna be our A data 2. So this will be data 1 and this will be data 2. So we're gonna be using 64 bits per block, or per vertex, which is a little bit sad. We can't smush it all into one, but you know, it is what it is, and this will allow us to have more data per block, so that's good. And how's it going, SC Woods? I hope you're doing all right. And Langors, glad to see you here. It's okay that you missed the stream. It's all good. You didn't miss too much. We're just sort of working through chunk compression still. So hopefully this is finally going to be like the last one and we'll get it done in this episode. But yeah. Okay, so basically goal is to move this out of here and move it into this texture. And then the data is going to be stored within these two integers, and we can sort of extract it and then uncompress it on the GPU, which should still save us another byte, which isn't a lot, but it does add up when you have like thousands of vertices per chunk. So this is definitely going to be useful, and I think it's worthwhile. Okay, so I'm going to be bold and delete that thing, and we're going to go into here, and we already have the texture generated, and we're uploading it and everything. All I have to do now is basically figure out how many bits we need in that new integer, which is going to be 2 bits, because we basically needed to encode top right, top left, bottom right, or bottom left. So that's 2 bits because we need 4 numbers. So I guess it'll just be 0, 1, 2, 3 will follow sort of the same vertex orders that we have for the texture coordinates when we load them, which is in here. Okay, yeah. So basically when we load the texture coordinates, we load them like this, and I can't remember which corner is which, but I believe this is like top right, left, bottom right. So it just kind of goes clockwise. Okay, so yeah. And how long will the stream be? Probably just like an hour and a half. So we need 2 more streams to hit Twitch affiliate, and that will be on Saturday. So this is like one of the last ones, and then it'll be like 2 streams weekly, I think, is what I'm gonna go for. And SC Woods, you said, do you have or use the Opengl shading language book? I don't have it. I've thought about getting it, but haven't really had a need to. So usually whenever I want to figure something out about GLSL, I'll just sort of go to Chronos, which is, I think I spelled that wrong. Yeah. It's basically like Opengl documentation. And so then you can just go to here. And if you're ever looking for a specific thing, this is pretty good. This isn't the best way though. I think it would probably be nice to actually read through a book, because then you can sort of see what's out there and get an idea of what to use. So I'll probably get a book at some point and sort of work through it just to see what's out there. And how's it going, Patat and Zolo? Hope you're doing all right. Okay, so now that we have all that out of the way, let's go ahead and go into the chunk, because we're gonna have to encode one more piece of information, which is the corner. So I'm going to go into here, and I sort of did this for all the other bit masks just because it makes it easier to know what you're doing. So I'm going to make one more bit mask, and this is going to be the texture coordinate corner, I guess. And this is just going to be the first 2 bits of that second 64-bit integer. So we should be able to encode this just by saying 0x3, right? Yeah, that should give us 2 bits, the first 2 bits. Okay, cool. So that should be good. And then we can sort of use this to bit mask that whole thing. And then we're also going to have to modify our vertex right here. Okay, and I already did this. So yeah, we're going to have a data 1 and a data 2, but we're going to be getting rid of this. So we're going to be saving a byte, and we'll have more room for storing extra information too, which is good. And is it Friday in your time zone? Eddie Dev says, no, it is still Thursday for me. It's 5 p.m. For me. So yeah. And it's 1 a.m. for you, Stefan Arctic. Wow. Yeah, I'd be going to bed soon too. I'm like an old man and go to bed at like 10. Okay. So anyways, we're going to be sort of smushing everything into here. And this is good because basically it'll just sort of mimic this block structure we have, right? We can sort of encode all the same stuff the way we do here. It'll be slightly different, but we'll have essentially the same thing. Okay, so anyways, if we go back into the chunk.cpp, we have this texture coordinate corner mask, and we want to go down to here where we're compressing the data, which is right here somewhere. Okay, right here, yeah. So we have compress. And we're going to want to make one more function, which is static. I guess this should be void is what I'm thinking, but this returns integers. So that's kind of weird. Maybe I don't have to do anything like that. Okay, so this says compress. This takes in the cube face, and then I'm going to take in one more thing here, which is just, we'll call this text corner. Or I guess, man, I don't know what to call this. We'll call this UV index. I guess that'll be good. So this will be the UV index, and we'll go ahead and create a structure or an enum to simulate this. So we'll just have enum class UV index, and this is just going to be a uint16, which technically this could be too. I guess I'll make them 32 bits. It doesn't really matter. Okay, anyways, so we'll have top right, and we may have to change the orders, but for now, this is how it'll be. Top left, and bottom right. So that should be good, and we can just sort of use these. And midnight for you tree. Wow. And SE Wood says, can I ask what resources I've used to figure out how Minecraft was built? Is it from source code? No. So I initially just started Googling things to try and find it out. I didn't want to look at the source code just because you have to like decompile it or whatever. And so it's never as good as the original stuff. But I found this course by Penny DeBile, I think. That's how you spell that. On Udemy, and it's literally just how to code Minecraft. Okay, yeah. So this is the course I initially followed, which really got me started into graphics programming in general. And it's okay, but I wouldn't recommend this as like a perfect course. But then I also found something. It was like Unreal Engine, voxel Minecraft clone that you could buy. And yeah, I think it was this thing. So yep, this, and it looks beautiful. And it's really cool. And so then I bought their source code for like $70 because I was like, I want to see how this works and stuff. And I basically just sort of went through their source code and then rebuilt it myself. And that gave me an even deeper understanding. And then I finally was like, okay, I'm going to try and build this by myself with just OpenGL. And that sort of started everything that I've been doing since then. So yeah. And to be fair, the Minecraft is known to be a complete code mess. I did not know that, but I'll take your word for it. Yeah, so the reason I didn't like Penny DeBile's course too was because it's in Unity. So first of all, it's in Unity and it's really slow and it doesn't really work very well. They also pose restrictions on how big of vertex, how big of structures you can build, right? So like they don't let you build a lot of vertices if you're doing custom objects for whatever reason. And it's just not the best format, I don't think. And then she also didn't like really go into how to build the whole game, which was kind of disappointing. So yeah, I'm hoping to rectify that though. And if anyone else is looking for how to code Minecraft, they'll be able to figure it all out from like the tutorial series that I'll make after this. So yeah. And Tree said, I don't think that Minecraft source code is public available. No, yeah, it's not. You have to decompile it. So that was another reason I didn't really want to look at the source code because it's just, I feel like it's ethically wrong, but I know many people probably do it, and I just didn't want to do it. So, you know, it is what it is. Okay, anyways, though, let's modify the for declaration right here. So we're taking in a cube face, and we're also taking a UV index, UV index. So that should give us the last little bit of information we need. And we can sort of go down here and fix the functions that we just broke, which are going to be these things. We should be getting an error. Yeah. Okay, so this is the bottom. Oh, actually, we don't even need to send that in too. Okay. Yeah, we don't even need to send that there because we can just sort of generate that stuff. So never mind about that. I'll still keep the UV index up there just so that I know what's what. And why does this not look happy? Oh, it's because I removed UVs. Okay, so this is going to be an I pointer now. This is going to be 1, and this is going to be a GL unsigned int. And we don't care about that. And this is going to be the offset of data 2. And this is offset of data 1. Cool. Okay. So if I go back down to here, the reason we don't need to pass in the UV index is because we have all that stuff right here. We just sort of have to assign it right here. So this compress function will sort of take care of that for us. And we can pass it in here to the compress function. So, oh, okay. So I put this in the right place. Cool. So I did put this in the right place. I just didn't put it in the right place here. Okay, and this is going to be data 1. Well, actually, we're going to have to return 2. Huh. What we're going to do, okay, this is going to return a vertex now because this is just going to be the easiest way to do this. So we're going to do this, basically remove all this stuff, and compress is going to return a vertex, and then we should be able to get rid of these UVs. We don't have to worry about that anymore. And hopefully we don't massively break everything. So this is now going to return a vertex, and it will just return all the stuff. So this will be data 1, and we'll say data 1 or equals all that stuff. And then we're going to return data 1 and data 2 and close that. And we need data 2, which is going to be 32 data 2 equals 0. And is this still accurate? I don't think this is. These bits have to be updated, but we'll do that later. Okay, so we've got all that set up now, and now we just want to encode the UV index into this data 2, which is going to be the first few bits. So we can just say data 2 or equals, and I'm just going to mimic what I did right up there, which is UV index shifted left 0, since this is the first portion, and this is going to be the UV index bit mask. I called it something else, but we're going to change that because it makes more sense this way. So we'll go back up here and change this from coordinator to UV index bit mask because that makes a lot more sense. Okay, anyways, if we go back down here now, yeah, so we should be good here. Doesn't like this because we need to cast this to a uint32, and now it's happy. Cool. And then we just return data 1, data 2. It doesn't like this because it says it expected a semicolon, which it does. Okay, so we're in a good place. Now that we've got this done, we need to go down here and figure out which corners are which here. So basically, this 0, 1, 2 is going to need a corner for all of these. So for now, I'll just say UV index top right corner. No, just top right. And then I'll do the same thing down here, and we'll just assign these once I figure out how this actually works. So we'll say top right here as well. And let me just look at my diagram very quickly. So I believe 0 is top right, 1 is bottom right, so we'll make that bottom right, and then 2 I believe is top left, which would make 3, or wait, am I looking at this right? Okay, so vertex 1 is top right, vertex 2 is bottom right, vertex 3 is top left, and then vertex 4 would be bottom left. Okay, and then so vert 1 is top right, so that's fine. Vert 3 is top left. Okay, so I think that's right. I might have to change that around because it's probably gonna be somewhat wrong, but we'll see. I'm gonna leave all of these here because this is gonna help out quite a bit. So this is all data 1. I think that's all I have to do. Yeah. And I'll do the same thing here. This is going to be data 1. Data 1 here as well. Once we actually release this or whatever, get it to a better point, and I'm confident, I'm going to remove all this. Yeah, remove this once you're confident you're getting the right value. So we will do that in a little bit, but make that data 1 as well. Okay, cool. So we've got all that, and this should be encoding it properly now. Let me just double check everything. Yep, so now we got data 2 in here, and this should be getting all that stuff set up as well. Okay, so now if we go back into the shader, we should be able to get stuff out of here. So we have a data 1 and we have a data 2. And we have this function extract text chords, which I made, which is going to do the heavy lifting for us. So basically, we want to get our f text chords from that data 2 and the texture and all that stuff. So we'll say extract. We're going to pass in a data 2. Well, we need both of them actually. So we'll say a data 1, a data 2, and then we'll pass in f text chords. Cool. So this is also going to take an uint data 2. So data 1 and data 2. And then right up here, I'm just going to define another bit mask to make this easier. So we'll say UV index bit mask is going to be uint, and I believe I said it was just 0x3, which is simple. And then I have one more bit mask that we're going to need, which is, if we look up here, the face bit mask. Yep. Or actually, the texture ID bit mask. That's the one. Okay. So if we go back into here, I'm just going to define that as well. And this is going to be whatever this is. So we'll copy that. Cool. So now these should all be proper and working good. And we can just sort of mimic what we did here to extract that information out. So what I'm going to do is I'll say uint texture ID equals, and we basically just want to get, not that, we'll say data 1 and not the face bit mask, but the texture ID bit mask. So that should give us the texture ID, and we need to shift that a certain amount too. So let me see how much I need to shift that real quickly. So we shifted it left 17 here, so we need to do shift right 17 in here. Okay, so we get the texture ID. Now we also need to get the texture coordinates, which we shifted left 0 here, so we just need to sort of get that thing. So we'll basically say uint text coordinate corner, or I guess UV index, that makes more sense. And this is just going to be data 2 and UV index bit mask shifted right 0. Okay, so that should do it. And now we can sort of use this information in conjunction with this texture and get all the information. Real quickly, I'm just going to adjust my microphone because it looks like it's moving a little bit. And SC Woods, you said the YouTube video I made on Stack Overflow, in your opinion, is a high quality video. Thanks. With regards to filming and editing, could you briefly describe how much it takes, time, equipment to get to that level of quality? So it really, I mean, it just depends on what you're trying to do and stuff and how much knowledge you have beforehand. So with that, it just takes a lot of trial and error, I guess. I don't know, because I've tried to do things similar in the past, and there's some videos that I have that I just kind of scrapped because I didn't like the way they turned out. So they're just sitting on my computer, but I haven't really done anything with it. I think that took me about a month to make though, just because I had to get all the information I needed. And then I try and write out scripts for things like that, just because it really helps to have a script whenever it's something that I really want to get a clear point across. And then I also try within the script to lay out like what I want the visuals to be. And that's probably the hardest part, is just finding good clips and stuff for all the visuals. And then once you have all that set up, the editing isn't too bad, but it still takes like a week to just edit all that stuff. But yeah, still pretty fun. Okay. So now that we have this stuff, we need to sample the texture, which we have right here. So we're going to say basically float UV0, or something like that, just text chords, right? We're just gonna say text chords dot x equals sampler, I guess sample this texture, and then where do we want to sample it from? We want to sample it from, see, now this is going to be the kind of hard part, is figuring out where to sample it from. Let's see. And yeah, no problem, Messy Woods. Okay, so if we go back into the block map, the way we set this up is down here. Okay, so basically we just allocate a bunch of floats, and then we say width is that, and we say the height is that. Okay, so we just sort of let them fall where they do, huh? I'm wondering if, so let's take a look real quick. So Opengl sample. So I wonder if we can sample just using an index instead of like an XY coordinate. Let's see. Sampler 2D. So if we look here, somewhere down here. Okay, so you use texture. Let's see. Texture GLSL. And if we go into here, cool. Okay, so this is what I'm looking for. So basically, we pass in a sampler, and then we pass in a float. And the G is just, if we look down here, okay, G is just, I think, like whatever type you have. Yeah, so it doesn't say it explicitly here, which is kind of annoying. But I believe like you would do a U if you're sampling for an unsigned in, or like just nothing there if it's like a float. And we're looking for a very specific one, which is going to take in sampler 2D. Oh, I guess we could pass in a sampler 1D. This is probably what we want. So what I'm going to do then is just change this to be a sampler 1D in here, and we'll see if it just works. I'm hoping it will, but I have no idea. So this is going to be a sampler 1D, and then we should be able to just say texture and then pass in the sampler and then pass in float P, and that's it. And it should work. So we should say texture, that, and then some float, which is going to be our index. And how do we get that index? Well, we can say float index equals, and we'll get that from the UV index plus this texture ID. Okay, so yeah, so we'll do a texture ID times 8, and this will have to be cast to a uint just so that we don't get problems, plus UV index, and then we'll cast all of this to a float. Okay, I think that's how we do it. Yeah. And this UV index, oh, this isn't actually like, okay, yeah. So then we also need to switch on whatever UV index is to get the vector. So we'll say vec2, not sure. Wait a second. Okay, I gotta think about this. So the UV index is gonna be like top left, top right. Yeah, okay. So then we can say vec2 corner equals, and then wait. Okay, I gotta think about this for a second. So if we look inside of the block map, okay, so the x is just plus 0 and then y is plus 1. Okay, so that makes sense. So we can say plus 0 will get us the x, and I guess this will be just 0.0 so that it's a float. And then we can do text chords.y, and that's going to be plus 1. Okay, so I think that should be good. I'm going to adjust my microphone again. Okay, cool. So I guess we should just see what happens. I don't think this is going to work because there's probably some problem with something I'm doing, or it'll be like half working. Let's just go with it and see what happens. I probably should have put an assertion too, just to make sure that I'm encoding that data correctly. Okay, yeah. So we broke immediately. What did we hit? Okay, so it just looks like I have an error in there. So it says undefined variable data1, data2. So what did I do wrong here? So this takes in data 1, data 2. That's fine. What I call, okay, so this is a data 1. So I just have to change this so that that's right, and change that so that that's right. What else did it say? It says undefined variable on line 38, which I'm assuming is like right around here, but I'm defining it right here, so I don't see why that would be a problem. Okay, let's see what happens this time. I'll just run it again and see what errors we get. Okay, so did not compile again. Yeah, so it's still saying undefined variable data 1, data 2. It's probably something I'm missing somewhere else. What's it saying? Undefined variable text chords and extract. So what did I do wrong? Okay, so text chords. Yeah, so this should all... Oh, okay, it's because I'm missing a comma here. That would help. So let's go back into here. Rerun this. Okay, now we get... So it says implicit narrowing of type from vec4 to float. So where is that? That's right here is what I'm guessing. Right here. So we'll say texture.r since we're using the red component. We should just need to get the red component and that should be fine. Okay, cool. So now what do we get? Okay, so another error. We're almost there. Undefined variable extract and unexpected identifier. Okay, did I miss something here too? So we have extract position. This should be extract text chords. Okay, right there. And now we should be good, hopefully. I really don't like writing shaders just because you have all of this stuff every time. It's like, it's not really easy to see if you have any errors because syntax highlighting kind of stinks and all that stuff. Okay, what's this say now? Unexpected identifier, expecting semicolon or a comma at ffrag position, which is right here. Oh, I'm missing a semicolon. Okay. Are we going to get it this time? Maybe. Okay. Nope. We have one more thing. So undefined variable a text chords, which is right here. Okay, so I just have to change that finally to be, well, actually, I'm assigning it inside of that function, so we shouldn't even have to worry about that. Or actually, I guess we do. Well, no, yeah, we don't even have to worry about that. So, yeah, we just assign it right there. Cool. So that should be good. Now let's see what happens. I'm having a feeling it's going to be weird, but probably get something. Okay, no, we'll get another error. Unexpected identifier, expecting comma or semicolon at text chords. So where is that coming from? Okay, so we say text chords. Oh, I'm missing a semicolon here too. Man, you'd think I would notice these things, but okay, there we go. It's finally going. And I think we might actually have this working. No, okay, yeah. So it's definitely not working. These are just like gray. So I'm gonna have to figure out what's going wrong there. But do I have any experience with coding in Unity? If so, do I like it? Yeah, I've coded in Unity before, and I just feel like it's too complicated. Not like it's too complicated, but I feel like it's just, I don't know. I just really don't like it that much. It's big and it's bulky, and it's just not what I would want when I'm developing a game. I want something that's lightweight. That's kind of funny because I'm developing in Visual Studio, but like I still feel like it's faster to start this up and compile my code than it is sometimes in Unity just to hit the play button. But yeah. And Tree, you said these errors are basically because of lack of great shader. Yeah, and it is very annoying. There is some shader syntax helper things within Visual Studio, but I don't like them because they give a lot of false errors and stuff. So I just chose to use VS Code and just like literally have the syntax highlighting, which is good enough for me. But yeah, if they showed red squiggles and stuff, I would probably notice this stuff a little bit sooner. Okay, So this isn't working correctly though. And as Wood says, I can imagine that's easier to customize your own engine. Yeah, that is true too. You can definitely customize it. And Langors, you said Unity takes so much time when you press play button and you have something more than just a plane. Yeah, even when you just have like a cube on the screen and you press the play button, it's like Unity takes so long to just start. And I looked into it. The reason it takes so long too is because basically the way that they built it is the whole editor just sort of rebuilds itself whenever you hit play, which is really stupid. And I don't know why they designed it that way. So like every time you press play, it basically has to go and recalculate everything because the editor was written in C#, which is also another problem because that means that's going to be slower code just in general. And they tried to fix it with dots and everything, but yeah. Okay. So anyways, let's first of all, to see if we're getting this right, very first thing I'm going to do is go into this chunk and we're going to add another assert here and just make sure we're getting the right thing. So we'll say assert extract corner vertex data vertex cursor plus 0.data2 equals and this should equal this, right? So we should just follow that thing. So and then we'll just say failed on corner. I guess this should be UV index. Okay, so then I'm going to go ahead and write this function real quick, and it's just basically going to be the exact same thing that we have in the shader, except it's going to return that, and we're going to take in a UN32 data 2, or just data, I guess. And I'm going to go into here, and we're going to go ahead and extract. Okay, so it's this thing, right? Yep. So just paste that there, and this is going to return that cast to a UV index, except that's going to be data, and we should be good. Cool. So as long as this all passes, we should be good. So we'll just do that, and then that, and it's going to be 1, 2, 3, 4, 5. I guess we could keep them together because it doesn't really matter too much. And then it should be bottom right next, and then top left, top right, and then top left, and then bottom left. Okay, so let's make sure that's all working properly. If that's all working properly, then we'll check it in the GPU, make sure it's all working. Okay, so that's all working because we're not getting any errors. That's good. So I have a feeling it's going to be like we're having issues with the way we're sampling the texture or something, which is going to be really annoying to figure out. Okay, but that's good. And Tree, you said, but even more annoying thing is that Visual Studio already has an amazing shader editing capabilities for HLSL, and don't know why they couldn't just do it for GLSL. Yeah, I've never used Visual Studio for HLSL, but yeah, I do expect that from Microsoft too. Okay, so this is all good. Let's go ahead and make sure it's working right on the shader side too. So what we'll do is we'll just say, we'll comment that out, and we'll assign the texture coordinates according to the corner. So let's see. We will say that, I think I said 0 is top right, so on and so forth. Let's just double check that. Okay, yeah, so 0 is top right, 1 is top left, 2 is bottom left, and 3 is bottom right. So we'll do switch on UV index case 0. We're gonna have top right, so we'll say text chords dot, or we'll just say text chords equals vec2 0 1, or no, 1 1 is top right. Break case 1 is top left, so that's gonna be vec2 top left is 0 1. Break case 2 is gonna be bottom left, so we'll do 0 0. Break case 3 is gonna be the only other one, which is bottom right, so that's gonna be vec2 1 0 break. Okay, cool. So that should assign the texture coordinates, and we should get some colorful blocks, but they should show us how those values are being assigned. Okay, so what do we get? Implicit cast from int to uint, of course. So if I go back into here, this should be switch on uint 0, because otherwise we won't have a happy compiler. So change that, and then we'll change that to 1, 2, 3. Okay. Now can we get this? Okay, so that worked. And let's see what we get. Okay, so this already doesn't look very right. Oh, okay, I guess it does kind of look right. So it's just showing us the whole texture. What I can do to fix that is we'll just go down here for now. And instead of sampling from the texture, which is coming from this object color, I think, yeah. So instead of doing that, I'm just going to say f text chords. We'll say vec4 f text chords, and we'll do 0, 1, and I'll comment that part out. Okay, let's go back into there, and we should get colors now this time. And I'm using a sampler 1D in the shader. Are you creating a texture 1D on the CPU side? Don't they have to match? I am not creating it on the CPU side, and I didn't know if they have to match. So that could very well be the problem I'm having here. Do you have any documentation you could link in the chat to show me how to create 1D texture on the CPU side? And S.E. Woods, you said, when will Xbox Series X arrive? Still not possible to get a hold of. This is not the case in the States. It's still pretty hard over in the United States, I think. My brother was able to get one, but I just haven't tried getting one, so yeah. And we have an implicit cast from vec4 to vec3. So I believe we should just change that and that. And you usually use docs.gl. Okay, I'll check those out in a minute. I just want to make sure that we're getting this data correct too. And then I will look and see how to create a 1D texture on CPU side. Okay, so yeah, so now we're getting some colorful stuff. And we should see this all hopefully being the right. So top right should be 1, 1, 1. Or no, 1, 1, 0. So that's RNG. What's red and green? I can't think. Okay, well here, we can tell right here. This is supposed to be the bottom left. So that's bottom left, top right. But that doesn't seem right too, because if we're mixing our red and green, it should be yellow. So top right should be yellow. Top left, yep, so that makes sense. So it looks like we have these swapped, which means the triangles are probably just going the opposite directions. I'll have to fix that. Yeah, but this is good though. This is definitely in the bottom left. And then we just have the top right. It looks like the top right and the bottom right are mixed up, right? Yeah, so let's fix that very quickly and then we'll move on from there. So if I go back into chunk, I just messed up right down here. So top right and bottom right are mixed up. So this should be bottom right. This should be top right. This should be bottom right. Okay, let's run this again and we should get the correct colors this time. Nope, we're going to get failed on UV index. What did I fail on? Oh, it's because I have to fix my assertions too. Okay, so this is going to be bottom right. This is going to be top right. And this is going to be bottom right. Cool. Okay, so if we run this again, we should be fine. And we should get correct colors. Nope. Did I mess something else out? Failed on UV index. Okay, so I'm still messing something up. Okay, so we have bottom right, top left, bottom right, top left, bottom left. So this should be bottom right, then top right, then bottom right. Is that right? I'm going to undo a bunch because I think I messed something up here. No, okay, keep that. Okay, cool. So we need to swap these. So this should be bottom right. This one should be top right. This one should be bottom right. Okay. Then this one should be bottom right. This one should be top right. And this one should be bottom right. Okay. Yeah, that's confusing. And Langors, you said, but I think it should be very simple to texture 2D. but not really use texture 1D, so I couldn't tell. Yeah, I'm hoping, I think it'll probably be simple too. I probably just have to change the way that I do my textures and stuff. So we'll check that out in a minute. Okay, so this is right now. Cool. So bottom left is black, and then bottom right is red, which is correct because if we think about it, 1, 0, X, which would be R, G. So we should get red. That's green, and that's yellow. Okay, cool. So these are all oriented the correct way. It's a good thing we checked that now and kind of got that out of the way. But now let's look at texture 1D because I believe that's the problem too. So texture 1D GL docs. Nope. OpenGL. Okay, GL text image 1D. Yeah, I usually just use Chronos. GL docs is definitely formatted nicer though. Okay, so anyways, it's basically the same stuff. We're just using GL text image 1D. We do target, level, internal format, width, so we don't have to do width and height. And then we do a border, which I believe is the same as the other thing. And then format, type, data. Okay, yeah, so it's basically the same thing. We just have to add a flag inside of my texture builder and everything. So I'll just add a flag here. Actually, I could just add a type, right? So I'll just have a texture type, and we'll create an enum up here. So enum class, texture, type. So we'll have 1D, 2D. Can we do that? We can't do that. So we'll do 1D with an underscore just so we don't violate variable naming conventions. 2D. And I think there's cube maps and all that stuff too. So that's why I'm doing it this way. And then we'll have none equals 0. And we can add more to this as we see fit. So then this is why I like builder objects too. You could just use a constructor to do what I'm doing here. The reason I do the builder object though is because this stays plain old data almost. It's technically not because of this, but it's almost plain old data and I like that better. Okay, so if we go back into here, right here I'm going to say texture.type equals texture type 2D by default. And then I'll add a function in here, which is just to set texture type. And then we can go into here and I'll implement that right below the swizzle, which is what I had here. So this will be set type, texture type, type. And then we'll just say, texture.type equals type, return star this. And Langors, you said textures just have way too many parameters for a normal constructor. Yeah, HTTP Digest put something in the Discord that sort of explained why OpenGL is designed the way it was. And I had a feeling that they did it that way for a reason. Like the reason they have this format and this type is because this is like the external format. So if your pixels that you're giving to it are in a different format, it automatically converts it here. But I feel like if they were going to do that, they should have just had another one, which is GL text image 2D or whatever, where you don't have to specify external format and it just uses the same format for internal and external and it simplifies everything. So that's basically what I've done with my API here. And I do really like this because it makes it quite simple to use. So once we have that, right here, we can say switch on the texture type. So we'll say texture type, or I guess it's just type. And we'll say case texture type 1D, one thing, and then break, and then case texture type 2D. We'll do that. And we'll break, and then we'll say default GL or G logger error, invalid texture format or texture type. And then I'll do that just so I know what it is, and we'll pass it the type. Okay, cool. So this time, if we just have a 1D, we'll do this. We'll take in a 1D texture. So this takes in, see, yeah, so like this says GL text sub image 2D. Why are they asking for the texture type here? I would assume that this is just a GL texture 2D, but you know, I guess instead of creating different functions, it's better to overload this and stuff. It is what it is. Okay, so anyways, target. So for text image, this needs to be texture 1D. Okay, so I guess this is why they take it in, because you could do 1D or a proxy texture, whatever that is. And I must type a lot of words per minute. It's not anything crazy. I think it's just like 80 words per minute, which is pretty normal with like most programmers, I think. If I really try, I can probably get up to like 90, 100, but it's not very accurate. IntelliSense, that's the key. Having good IntelliSense and auto-completion. So yeah. Anyways, so we'll use texture 1D. And then the next thing is the level. So we're going to leave that at level 0. We may want to customize that in the future. So then next thing is the internal format. So this must be one of these things. Do they have GL red? Let's see. They've got a lot more things here. So, okay, yeah. So here we go. We got GL R3, G3B2, RGB. Do they not just have GL red? Because I think that's what I was using before, and it would be really nice if I could keep using that. I might have to just do GL alpha or something. Let's see, red. No, yeah, they definitely don't have GL red. But then you can do that as the external format. Okay, specifies the number of color components in the texture. Must be 1, 2, 3, or 4, or one of the following symbolic constants. Okay, so I guess we'll just do GL alpha. So it's just gonna be stored in the alpha channel, which is fine because it's still the same thing. Yeah, I would prefer it to be like GL red, but they don't give that option. So yeah, not anywhere that I see at least. And I assume that we can just still do the type as GL float, yeah. And then the format will be GL red for the external format. Okay, cool. So we don't need this offset. Oh, this is GL text sub image too. I need to, first of all, copy that and go down to wherever I create them, which I believe is, okay, yeah, so right here and right here. Okay. So we will switch on texture.type here. And this is going to be this, and we'll get rid of that. And this is going to be texture.type. And then this is going to be basically the same thing as this, except 1D. So I'll change that. That should be 1D. So 0, and then we're going to use internal format, which is going to have to be GL alpha now. Yeah, so I'm fine with that. So let's go into here and we'll add in, okay, so I already have that, well, right up here. So I'll have a alpha UI. We'll have an alpha F because I want this to be a float. And will I ever put my tutorials behind paywalls? I see some do that. No. I believe that all information should be free for like learning and stuff, because I just think it's stupid to put it behind a paywall. Like, if people really appreciate what you taught them, then you'll end up making the money one way or the other. If you're a crappy teacher though, and you're not actually helping people, then why should they help you beforehand, right? So yeah, I think it's definitely of the case, like, you should put your work out there, and if people appreciate it, then they can contribute if they want. It's really difficult to do stuff like that though, because you always have people who take advantage, and it's just something that's kind of difficult to decide. Okay, anyways though, we've got this alpha F, and I just need to go add support for that in all the other places. So byte format is int. Okay, so yeah, I just need to sort of add it in to all of these. So 2GL, we don't care about that. We don't care about that right here. This is to internal format. So case byte format that, and we return GL alpha 32F. Do we have that? 32F. No, I think we just do GL alpha. So we'll leave it at that. Let's see what this, just double check one more time. Yeah, so this is just GL alpha, and I assume it'll be 32 bits and it'll all work out magically. Okay, so format will be GL alpha. So we also return that for external format, case byte format alpha. Return that. And I'm just going to move that up one. And then the last one is the type, which is going to be float, right? Because that's what we're using. GL float. Yes. Cool. So if we go down to here, we can say case byte format alpha return float. Okay, so that should take care of everything. We should be able to use it now. I guess I could technically add it in here as well, and I probably should. So case byte format alpha return false. This is not an integer. And is it RGB? No, it is not. So I'll return false there. And we should be good. Cool. So that takes care of this. And then I have to do one more of these right here. And we should be good. So change this to right there. We shouldn't ever get a 1D texture with STB. So if this happens, I'm just going to say glogger error. Cannot use 1D texture with STB. Break. Okay, cool. And you said that's why you have asked about donations, but you'll wait. Oh, I appreciate that, SC Woods. I really do. And it's one of the things, like YouTube is already, I make like what, $40 a month or something like that from YouTube, which isn't a lot at all, but you know, it's nice to have that, and it helps me buy a couple pieces of equipment every now and then. So I have a good job, and I definitely don't need any extra money right now, which is why I've sort of held off on that. And I've always like said to myself that if I hit like 10,000 subscribers, then I'll probably open up a Patreon and that type of stuff. Just because, I don't know, I'll feel like I've crossed some threshold then. So yeah. Or once I hit a Twitch affiliate too. Okay, anyways, though, so we've got texture 1D support, 2D support up here. And I also need to add in, finish this text sub image 1D. Okay, so we'll go into here, GL text image sub image 1D, and right there. So this is going to take target level X offset with format type pixels. So we got offset X width, and we don't need a height because it's just 1D. I might separate this into two functions. For now, I don't really care, so I'll just leave it. But yeah, and then it's format type pixels, format type pixels. Okay, yeah, so that works for me. I may change it in the future. Anyways, if we go back down to here, though, we can say dot set type to texture type 1D. Thank you, Langors, for mentioning that. We should finally have this done now. And then the width, I'm just going to set to the number of textures times 8, which is really what the width is. So if we go into here, we can set that, and we should be good there. And we no longer need to do that. Okay, so let's go back into the shader, and then we will take this stuff back in again. So I'll just remove this since we're confident that that's working properly now. And I'll take this stuff back in too. And we'll see what happens. With some luck, maybe it'll actually work. Okay, I miss some arguments here. Too many arguments, actually. Oh yeah, because this is text image 1D. So we have internal format width. We do not have height. Border 0 format type pixels. Okay, so do that one more time. And it's working. And this did not work. Yeah, so we're just getting a black texture. I mean, this is a good sign though. Oh, and you know why that is. Actually, maybe this is a sign that it is working, because I used the alpha. I didn't use R, so we just have to change this to A. Okay, let's see what happens now. Yes, the shadow realm. It'll be a special biome. Okay, now it's yellow. That's still not right, but it's definitely giving us something. So that's good to know. It's just not giving us anything close to the right thing. I don't know what realm this is. The sun. Okay, so why would it be giving us yellow? That's weird. Because now I'm actually... Oh, wait, I know why it is, actually. I forgot one other thing that I had done. It's this. Okay. So now if we do this, let's see what happens. With any luck, it'll work. Cheese realm. Yeah, that's a good one. Okay, cool. So this isn't right either. I guess this is like the static realm. I don't know. This is when it gets fun, right? When you start getting weird things like this. I think what's happening here is it's just floating point error. That's why it's flickering too, like this. We're just not getting any real textures though. This could be because it's all stone too though. And it's just flickering between those. Yeah, this is weird. Oh, I should probably check this thing out too, because text parameter I is probably expecting GL text parameter I. So we should probably be doing 2D or 1D depending on what it is. Target, 1D, 2D, so on and so forth. I'm just going to change this to say uint32 type equals texture dot type equals GL texture 2D. We'll do, or actually not GL texture 2D, but equals texture type 2D. Actually, I'm gonna move this to the new line. This is how I prefer to do these. If it's that, we'll do GL texture 2D. Otherwise, if texture dot type equals 1D, we'll do GL texture 1D. Otherwise, we'll do GL texture none, or just GL none, which is just 0. Okay, cool. So we'll just use that type here, 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 and there, and there. Okay. I don't think this is the problem though, because if we look at the block map, yeah, we have the filter set to none. We have the wrap set to none. So that shouldn't really matter. Oh, this is probably why too. This should be alpha. Okay, so that's kind of important as well. Let's see what happens now. Okay, so. Okay, it still looks pretty bad. I can't tell if this is any better or not though. Yeah, it definitely doesn't look any better. It's really weird that it's giving me anything at all though. I'm wondering if there's some weirdness going on from like the conversion when it's converting from the floats on my machine to whatever OpenGL is using for the floats, but I feel like that should be fine. So if we go back into here, when we sample it, this is expecting a float, and I feel like this could be the problem because, whoops, that should be 0. If it's expecting a float, and then it's giving us back a float too and stuff, it could just be doing some weird stuff there. And I moved that there somehow. Huh. Let's look at this function one more time. So, or actually, let's say how to sample texture OpenGL at exact coordinate. Let's see, because this is what we want to do. Okay, so let's say texture is 8 pixels wide. We get from 0.0 there to 1.0 there. The digits denote texture's pixel, so you're interested in texture coordinates 0/8 plus 1/8, so on and so forth. If you want to perfectly align your texture with the screen pixels, remember that you specify as coordinates are not a quads pixels. Okay, this is not what I'm looking for. Come on. I want to look for the exact texture sampling precision problems. Maybe this is it. Nope, this doesn't look like what I'm looking for either. Let's see. Okay, finding the pixel color in a specific corner, yes, this is what I'm looking for. Okay, so the fragment shader has a built-in value called fragchord that supplies the pixel coordinates of the target fragment. You must divide this by the width and the height of the viewport to get the texture coordinates for the lookup. So I'm not using this in the fragment shader though. I'm using this in the vertex shader. So I would suspect that that doesn't matter. Somebody's got to have some stuff on this, right? Okay, let's say Opengl, how to sample texture, 1D texture at an index. I've done this before too, so I might look at some old code that I have. Well, let's just see this real quickly too. No, it doesn't look like he's giving. I'm going to look at some old code I have because I have done this before with another thing, and it was painful when I was doing that too. So maybe I can look at my code and it'll jog some memories. So this was the true type parser I had. And as you said, have I ever considered making and releasing any type of application software? Like you bought a game organizing tool that a game developer released on Steam, actually. It's pretty neat. Yeah, I have thought about like applications and stuff too, but I've always been interested in games, and I think that's really what I gravitate towards. If anything, I think I'd release something like a game engine, but I do want to turn this, what I'm working on now, into an actual game. Me and my brother have kind of talked about this a little bit, but we basically want to make a game which is almost like a mixture of Minecraft and Terraria, and just adding a lot of neat features. And the premise is, instead of you're like in a open-ended world like Minecraft, you're on an island, sort of like Terraria. So you have ocean all around you, and then you have all the biomes on the island, and just sort of making it more dungeon-like and stuff. So yeah, I have thought about releasing something, and this would be it. So I plan on working on that after I finish this to a good degree and start doing the tutorials on this. And I'll keep streaming as I'm working on that too, and hopefully it'll be something cool. Okay, so if we look into here, I think it's in here, possibly. No, let's go into true type examples. Okay, yeah, assets, font shader, SDF shader, this one. Okay, yeah, so this was a pretty heavy duty shader that was not fun to write. But if I look up here, let's see. Okay, yeah. So I take in a unit form, which is a uSampler buffer. What is that? Because that might actually work better for what we're doing. uSampler buffer. Okay, so let's check this out real quickly, because this might be what we're looking for. Okay, so a sampler buffer is a texture buffer. And do they have anything? Okay, buffer texture. Yeah, let's take a look at this. A buffer texture is a one-dimensional texture whose storage comes from a buffer object. They are used to allow a shader to access a large table of memory that is managed by a buffer object. This is what we want. This is why I looked at old code, because I knew I would find it there. And that's cool. And you've played Terraria as well. Yes, Terraria is fun. When do I want to start making the tutorials? So I still need to finish the 2D game engine, which is pretty close. I've got like just this much left to do. I have to add a couple more things to get Mario done. And then I also want to get the C++ series a little bit further, so that if you don't know C++, you can follow that, and it's not like I'm leaving all the people who know Java only out. So I just have to do a few more tutorials with that to get it to a point I'm pretty happy with. And then I'll just start with this tutorial series. I'm hoping by that point too, we'll have this in a pretty good place so that I can be like, hey, this is what we will be building, and show them exactly what we'll be building. Because I always appreciate when a tutorial does that at the beginning. Okay, so when creating a regular texture, the user calls genTextures, binds the texture object, and calls one of the texture storage creation functions. Creating buffer textures is very similar. We call genTextures, we bind the texture, and we bind to the texture buffer target. Creating the storage for the buffer is the main difference. Buffer textures are defined by the fact that the storage for the text comes directly from a buffer object. Therefore, text image calls are not appropriate for buffer textures, calling any of the GL image functions. Okay, so that's kind of cool. On the GL texture buffer will result in an error. Instead of creating a storage for a buffer texture, the user associates a buffer texture with an existing buffer object. This association is made by binding the buffer texture to the GL texture buffer target and calling this function. So then we bind it and we call GL text buffer. The target parameter can only be texture buffer. Okay, so that's fine. Internal format is the image format. Okay. So we can do just a GL red, I think. Let's see. Yeah, so we can do like things like this. Okay, we'll look at that in a minute. Describing how the pixel data is stored. The buffer is created by buffer object. 0 can be used to detach it from the texture. The buffer must be created before this call. Buffer object target is texture buffer. Okay. As stated, this is not required. Note that while it attaches the whole thing, the texture can only access up to GL max texture buffer size texels. Huh. Any storage beyond this is inaccessible. Okay, so this might not be very good. What is this, though? How big is that? Max buffer texture size. It should be between 64 and 128 megabytes on all. Okay, yeah. 64 and 128 megabytes should be plenty. Okay, so I don't have to worry about that. Let me just check this real quickly, too. And the way I followed through it and actually finished the tutorial is so good. Thanks, Hussy Woods. Sometimes I'm not that good about finishing it to a point that I really like, but I do try and get it so that it's like at the end of the tutorial series, you still have something to show for it, which is hopefully what we'll have by the end of this series too. Okay, so we should be good with the max buffer size. That should be between 64 and 128 megabytes, so that's fine. The above method binds the entire buffer object. We can add some checks too, just to make sure we don't exceed that. The shader can access any value stored in the buffer. It requires the shader to be written specifically for this. So we can say text buffer range, so we can buffer a sub portion to the offset specifies a byte offset from the beginning, and it must be aligned to the offset alignment. Okay, cool. Oh, okay, and they have the image format here. Normal textures hide the binary. Byte order is important, blah, blah, blah. So we can do R32F, which is what we're going to want to do. Okay, so let's just try and use this real quickly. I'm going to have to change the way I'm doing it inside a block map. Instead of doing all this stuff, we're not actually going to use a texture. Well, they said that you can use it like a texture, but it's not really a texture. So yeah, so this is just going to say, how do we use this real quickly? So if we look back into the world, we basically just say somewhere up here. Okay, yeah, so we basically just say bind the texture, and then so we can get rid of this pretty easily just by saying GL bind texture. I think that's it, yeah. GL texture buffer, and then we'll give it this ID. Okay, so we'll change this to this, and this will return a uint32. So that should be fine. Cool. Okay. And then we'll go into, so that's this. We'll go into here, and this is going to return just the buffer ID. So it's basically gonna be like a VBO almost. It's like a vertex buffer object, except it's not. So we'll scroll back up here. This will now be a uint32, and this will be an ID, but it's more like a VBO ID because that's actually what it kind of is. And then right here we'll create it, and the way we can create it is way easier because we can just say, let's see, we'll say GL gen buffers 1, and we'll give it the texture ID. Okay, so that'll generate the buffer, and then we'll bind the buffer, GL texture buffer, and we'll give it this guy. And then we need to buffer data, and then we need to bind it. right? So this says we need to, so when creating it, the user calls glgen textures, bind the texture to, okay, well that's saying when creating regular texture. Creating buffer texture is similar. glgen textures is still used to create the texture object. And gl bind texture still binds it. For buffer textures, the texture is bound to this. Creating storage is the main difference. Do they have any examples? See, they don't have any examples here too. This is the annoying part. But we're very close. So, okay, so we still need to call like glgen textures and stuff like that too. The texels come from a buffer object. The gltext image are not appropriate. So in an error, instead of creating storage for a buffer texture, the user associates a buffer texture with an already existing buffer object. This association is made by binding the buffer texture to this and then calling this function. Okay, so we do still create. Okay, so what we're gonna have to do, from what I understand, is we're gonna have to basically say uint32 text chords buffer ID. So we're gonna have a buffer ID and we're gonna have a texture ID. And these are two separate things. And so basically this will be the buffer ID. So we'll say text chords buffer ID. And so we're gonna bind that buffer and then we're gonna say buffer data. And we're gonna say this is a texture buffer. We're gonna give it size of whatever this is, right? The same size that we have here. So I'll just copy that and we'll paste it there. And then we're gonna say the data, which is this stuff right here. And then finally we'll say the usage, which is just gonna be static draw. I don't think it really matters too much because I don't think it's gonna pay attention to that. Okay, anyways though, so we bind it, we give it the size, and then we upload it. Yeah, and I think that should be good. And then we need to generate the texture. So then we say glgen textures, and we're gonna say one and text chords texture ID. Okay, so we're gonna do that, and this is wrong. There we go, now it's right. And then we're gonna say bind texture, gl texture buffer. Oh, and I buffered the data wrong too. I'm gonna have to go over that one more time. And we're gonna bind text chords texture ID, and then I'm gonna have to somehow get that stuff up. And as Woods, you said, at some point the viewer of your tutorials must be able to try and figure out how to code on their own. The Mario project have definitely covered the main topics. Yeah, I agree too. But it's really hard to create a tutorial that helps somebody write on their own. With the next series, so like with the Minecraft series, I plan on giving a lot of challenges to the viewer. So like I'm not going to code the whole thing on screen. Instead, I'm going to give most of what you need and I'm going to explain the concepts. And then at the end, I'm going to have the user implement it themselves and I'm not going to give them the answer, because I think that the best way to learn is if you actually do it yourself. And so I think I'm going to try and do a lot more concepts and then be like, okay, this is how you would do it, but now you need to go do it yourself and I'm not even going to show you. So I'm going to take a whole different approach and hopefully it will help people out more than this sort of style where I've just coded and then you follow along, because I don't think that's very helpful in the long run. Okay. Anyways though, so we created the texture and we buffered that data wrong. So we need to do this text buffer call. This is how we're supposed to do it. So it says this association is made by binding the buffer to the texture buffer target and then calling this function. Okay, cool. So we did do the buffer right there. Then what we're going to do is we're going to give it texture buffer internal format, which we already says could be R32F. And then the buffer, which is going to be our text chords buffer ID. Okay. So that should do everything we need it to do. So we basically upload the data here to a regular buffer. And let's just make sure we did that right. The buffer object must have been created. The buffer object targets texture buffer also. Okay, cool. So that's right. Whoops. And then we create a texture and we bind the texture and then we text buffer this thing. And I think that should be all we need to do. And then just to be safe, we'll say GL bind buffer texture buffer 0, and we'll bind texture 0 as well. So we'll just unbind them afterwards. Okay, let's see. And you, S.E. Woods, you said sounds great, but I was in no way criticizing. Oh yeah, no, I don't think you were. Don't worry about that. I criticize myself because the questions I see on my tutorial series there, some people do learn very well from the technique I showed, but it seems like a lot of people aren't actually grasping the concepts and they're more just following the code and writing down the code exactly. So I want to change it up and see if I can help people actually learn a little bit better. And I think the method that I used is perfectly fine too for a lot of different types of people. So it just depends on your personality and everything and how you go about learning. And it's really hard to get a good tutorial. The best tutorial, this is a tangent, but the best tutorial ever, if you guys want to follow it, is this book, Crafting Interpreters. Yeah, right here. It's free, so you have no excuse, okay? This is so amazing. You can buy it too, which I'm going to do because I love Bob Nystrom. He's just a great author. So you can go read it here. And this goes through creating in Java first. So it's Java. And then in C, how to create a programming language. And at the end of every single one of his chapters, he has this thing down here, which is, if we get to the bottom. Okay, yeah, challenges. So he just gives some questions and he does not provide the answers. So if you want extra features in your programming language, you have to do these challenges. And this helped me learn so good. Like, this author is just amazing. So if you have a chance, read this book and like actually work through it because you'll learn a ton. I still need to finish the C portion of it, but it's amazing. And that author is just awesome. So, okay, so this text chords texture ID. What's wrong with this? Cannot overload function. Oh, there we go. Okay, so we're going to bind the texture there and then we're going to upload it and hopefully this should just work. Oh, and I forgot the most important part, which was changing the shader. So I have to do that too, which I will in just a second. This probably isn't going to work right. Yeah, so this is still very wrong, but we're getting closer. And bookmarked, good. Yes, everyone should bookmark it. Okay, so the last thing I have to do is now that I'm using this uSampler buffer, first of all, I have to signify that I am, and it's just a sampler buffer because we're using floats. So let's change this to a sampler buffer. And how did I use it? So the way I used it in here, the reason I'm using this too is because with the sampler buffer, you can actually specify an index and it's going to give you that exact index and it's not going to do weird interpolation stuff, which is why this is good. Okay, so we use texel fetch to do this. Texel fetch, and then you just provide the index and you get it. So if we go back into here and we change this to texel fetch, we're going to do texel fetch the uTexture index plus 0.0, and this is going to be .r, and we should be able to use that instead of this. And we can use the same thing here, except we'll add 1.0. And actually, texel fetch might take an integer. Well, let me check that too. If it does, that's even better, because that is what we want. Opengl. Let's just double check that very quickly. It does. It takes an integer. Awesome. So that is what we want, because that gives us absolute control. So we're going to say that this is an integer, and we're going to cast it to an integer instead. And now we can index directly into there. And this is just index, not x index. So we'll fix that too. Okay, let's see what happens now. With any luck, this will just work and it'll be amazing, but I have my doubts. Yeah. Actually, it's doing something right. Okay, wait a second. Okay, so it looks like it's definitely indexing into there okay. I just didn't upload it properly. Yeah, and these are definitely different blocks. It's just sampling from the wrong parts of the texture. This is good, guys. We're finally almost there. And I still am using up the funny, I guess this is the sad part. Actually, no, yeah, look. So before I did this, this was at 1.3 gigabytes. So just by removing 1 byte from our vertex specification, I reduced it to 900 megabytes, which is like a 400 megabyte difference. That's pretty big savings for 1 byte. And we'll save even more too in the next episode when I do some more optimization. Because this is still way too high and there's no need for it to be. But yeah, this is really good. It may not look good, but we're like just about there. So what is going wrong here? It's sampling from the wrong portion. So either the floats are getting converted improperly, which is what I have a feeling is problem. I have a feeling it's happening. So if we go into here, so we bind the buffer and then we just sort of buffer the data. And I don't think it matters how we do that, but how do we specify? Okay, yeah, and then right here is how we specify the format, which is we just say it's an R32F. Let's see if we need to do anything else real quickly. So we create the storage, and then the GL text image calls are not appropriate for buffer textures. Okay, that makes sense. So we bind the buffer texture. Okay, we did that. We use the internal format, but how do we tell it what the format of the pixels we're sending are? I think that's just sort of embedded within the buffer itself. So Langors, by the way, do you remember my suggestion Friday stream of dismissing vertex data that is adjacent? Yes, that is exactly what I was talking about too when I was saying that there's more optimizations to come. So basically, right now I'm just sort of creating a giant block, but instead what we're going to do is just create enough vertex data for all the blocks that are there. So I'm just going to cut out all the empty blocks that we have, and that should reduce a pretty massive amount of space. So that's definitely the last step in this whole sort of optimization process. And once we get there, we'll be in a really good place and I will be happy with where we're at and we can move on. So yeah, I do appreciate that suggestion too. So let's see. It says no texture parameters are legal to set on buffer textures. Okay, so that's good. And we can access them with the texel fetch function. Okay, buffers have a size limit. The buffer texture size limit is typically larger than that of a one-dimensional texture. This size in texels is this thing. The smallest number this will return is 65,536. So we should definitely be fine there. Okay, cool. So buffer textures are not mip-mapped. That's also good. They cannot use any filtering. That's also good. So in essence, a buffer texture is simply a way for the shader to access a large array of data, which is exactly what we want, generally larger than uniform buffer objects will allow. Buffer textures cannot be attached to frame texture objects. Okay, so that's all fine. I think what we're going wrong with is probably this. So let's see what this says for buffer data. Opengl. I don't think we're doing this wrong, but you never know. So we have this target size data pointer. Target specifies what we're using, and we are using a texture buffer, which is right here. So we're good with that. Purpose is to texture data buffer. Yeah, that's fine. Size, that's self-explanatory. Data, which we did, and then usage. So it must be one of these, and I'm just doing static draw, which is fine. Yeah, so I don't think there's any problems with that. So I'm wondering, it's probably something to do with this. Yeah. So this is probably gonna have to wait. I'm probably gonna handle this off stream just because it'll be a little bit easier for me to think about this and stuff. But this is definitely working properly. It's just giving me the wrong coordinates right now, which I can fix if I can figure out how to get the right coordinates, which clearly that makes sense. But yeah, I'm happy with this though. we're almost done compressing the data. And then the last step, like Langors just mentioned, is to sort of get rid of all the empty vertices that I don't actually have. I hope you guys enjoyed this stream though. I will be streaming again Saturday morning at the usual time. So if you're able to, I'll see you then. But yeah, thanks for coming guys. And it was a lot of fun. And I hope you guys enjoyed it.